Hello everyone! This is our second to the last video for Math 7. This video is concerned on the last lesson, which is on the introduction of circles. Please be guided that circles are non-polygons. And there is still a great debate for that, but let's not focus on that one. Our concern here is to come up with a better understanding on the terms associated with a circle as you go later on to higher level mathematics, you would already know what are the basic concepts so that you could actually proceed to the computational processes or other relationships for circles. Here we are tasked to determine or name the given terms associated with the circle here. So number one, we are going to name the circle in this figure. We are going to name the points on the circle, radii, the chords, diameters, secant lines, tangent lines, and tangent points of tangency. So for number one, we are going to name this circle here. As for naming a circle, we just simply need to look at the center. The center of the circle is already giving us its name. As for this given figure, the center here is at A. So we can name this circle as circle A. Since A is a point, we use here a capital letter. So we could actually name the circle in any other ways or with any other labels that we want. As of this figure is concerned, the center is at A. And take note, the center is one of the most important terms in that is associated with a circle, because using that we could come up then with the radius or the radii, the plural of it. We could also say that a chord is a diameter if it passes through it, and we have also angles forming in a circle with concern to our center. So number two is all about naming the points on the circle. In our module, I have made mention that there are three different groups of points that we could actually see in a figure involving circle. Number one, we have points in the circle. Number two, points on the circle. And number three is points outside the circle. If we say in, that includes the center because we are talking about the points that is actually enclosed by the arc forming a circle. And if we talk about outside, clearly we have the points outside. But if we talk about points on the circle, we are going to pick the points that are found on the circumference of the circle or that are found on the arcs forming the circle. So we are actually having here the points B. Counterclockwise, you have D, and you have here C, or B, C, and D. And then again, please be guided that we are determining here points. That is why we used here the proper way of naming points. We use the capital letters. And you can interchange them anyway because we don't have a concern on arrangements. All right. Just to clarify, point A as the center is a point in the circle, and point E is a point outside the circle. The importance of these points on the circle will again matter as we determine later on the line segments that are associated with the circle. So with these points on the circle and the center itself, when we connect them, we can have the different line segments. And one of which is in number three, the radii. The radii is a plural for radius. So radius is actually a line segment drawn from a center to any point on the circle. So if we talk about the center, we have here A, and since we have these 3 points on the circle, simply pair it with them. So you have A, B, right? This is now a line segment drawn from the center A to a point on the circle, which is point B. But then again, I have mentioned that they are line segments, or a radius is a line segment. So we need to make here the proper notation. Sir, what if I will answer here BA? Is it correct? Now, some of you might say, no, it's wrong because the definition of a radius is a line segment drawn from the center to any point on the circle. Well, etymologically speaking, that's a correct statement. Center to any point on the circle. That's correct. However, again, line segments, regardless of which endpoint is written first, are just the same. So by means of um, just by observing the nature of line segment, they are just the same. So they will be counted as one. So we will still accept BA. Even if you will say, sir, if it's BA, that would mean B is the center and A is the point in the circle. I don't necessarily concern with that because we are observing here the nature of line segment. So that's the first pair. Next is center A to a point on the circle D line segment. And we have center A and point on the circle C. So we have 3 points on the circle as of the figure is concerned. That is why we have three uh, knowns, known rather, three known radius. What if I have here a point, let's say point F? Definitely you could add it in number two and you can say you have point F. However, do not say I will add here a radius, sir, because I have a center to a point on the circle. Yes, we could come up with this, but as of the figure is concerned, there is no line segment connecting them. So if there is no claim or there is no figure connecting them, do not just simply write this one. Okay? That would also automatically mean that again, in this circumference, there are infinitely many points. I repeat, there are infinitely many points, and as therefore you can make infinitely many radii. Okay, many radii. But as of the figure is concerned, given by the figure, so we are only going to focus on what is given on the figure. So since we are only given with those notations, we will stick with them. Next would be chords. The chords are line segments connecting any point on the circle, any 2 points. So we have these 3 points on the circle. Look at the line segments connecting them. So we have here B, C. Sir, it's a line. It is actually a second, sir, to which will be answer for number six later. Yes, but if you're just going to look at this, if we're just going to look at this area here, it's still a chord. That would mean a second contains a chord. I repeat, a second contains a chord. But let's proceed with number four. Chord. That would mean we have here chord B, C. And we have that. Okay? Or chord CB. How about BD? Do we have a chord BD? If we are going to draw, then we have a chord BD. But for the figure is concerned, they are not connected. We cannot write chord BD. Again, we will only focus on what is the given figure. That's the concern, using the given figure. Okay. And finally, we have here DC. So we have D, C, or chord C, D. Okay. It's still a chord, but it's a special chord as it passes through the center. Okay. So these are the answers for number four. Now, let's go back to chord DC. It passes through the center. And any chord that passes through the center is considered to be our largest or longest chord. And that longest chord is what we know as a diameter. So for this given figure, we have here diameter for number five. So we will be having the chord DC or the diameter DC and say line segment, we have that. Okay, that is actually number 5. How about number 6? Number 6 is concerned on second lines. Now, second lines or a second line is a line that passes the circle at exactly 2 points, 2 points on the circle. So we have this line here that passes circle A at point B and C. So this is a second line. So I would write here B, C. And since it's a line, I would like to use here the proper notation for line. What is the difference between second BC to chord BC here? Earlier, we have made mention that BC, chord BC here is part of second. That would mean again, seconds contain chords. That's correct. Okay. But the difference between them is that, of course, it's a line segment and and it's a line. The second line is a line, so what do you call it? It extends to infinity for number 6. Okay, and as for the second line, it is actually the second line that contains the diameter DC. So we have here line DC. And by the way, do not use DAC anymore. Even in number 5, you might use DAC because it passes through A. Not use them. You may just simply use two important endpoints for line segment and the two last points for the each direction for second. That's why we have DC and BC. Again, the difference between these lines and the line segments, they contain them. And of course, they extend towards infinity. The lines extend to infinity. Number 7 is concerned on tangent line. Okay, the tangent line is different to second line because the tangent line only intersects the circle at exactly 1 point. And that is actually the line drawn here, as this line only intersects circle A at the point on the circle C. So how do we name this? The reason why I added here this point so that we could name it with two different points. So you have C, E, or line EC. They are just the same. Okay. Number 8 is connected to number 7. If there are tangent lines, then we can determine the points of tangency. If there are no tangent line, then we cannot determine the points of tangency. For the point of tangency is the point on the circle that the tangent line touches. And that is actually this point here. And since it's point, we are just simply going to use here the capital letter C. So these are the first uh, terms associated with a circle. We do have here the groups of points, and we have the line segments and lines. So the points could be used as naming the center or the circle itself. And we have three groups of points. We have points in, points on, and points outside. And with those points, we could actually draw line segments, which could be either a radius, a chord, or a diameter. Okay, and then the lines, which would actually be considered to be a second line or a tangent line, and the point of tangency associated with tangent line. The second practice exercise, which would be our last on the same given figure, would be the other terms associated with a circle, which in the forms of angles and arcs. So please stay tuned with that. Use this video as part of your review, and please be excited for our last video later on. Goodbye, everyone.